Welcome to another video. Today we are looking at the Stanford Math Tournament question of 2018. So let's see how we can solve this integral. So this integral I is from 0 to pi of 2x sine x over 3 plus cosine of 2x. So we can start off by rewriting what cosine 2x is. So this is cosine square x minus sine square x. But we know that sine square x is the same as 1 minus cosine square x from the Pythagorean identities. So this one simplifies to 2 cosine square x minus 1. So we can just plug that into our integral. Okay, so we have I, the integral, to be equal to the integral from 0 to pi of 2x sine x divided by 3 plus 2 cosine square x minus 1 dx. So this is equal to the integral from 0 to pi of 2x sine x divided by 3 minus 1 is 2 plus 2 cosine square x dx. And this one evaluates to integral from 0 to pi of 2x sine x divided by 2 into 1 plus cosine square x dx, like this. Alright, cool. So the integral I is the integral from 0 to pi of these two, cancel these two, and we are left with x sine x at the top, divided by 1 plus cosine square x, like this dx. Okay, so here we are now going to do integration by parts, if that can be done. So here, what I'm going to do here is to do the shortcut method, di method. I am going to just differentiate only x. Normally this is plus and the next one is minus, and I am going to integrate the remainder, which is sine of x divided by 1 plus cosine square x. So if we are able to integrate this, then we can solve this integral. So I am going to do that here quickly. So if we are going to integrate sine of x over 1 plus cosine square x dx, this one I can multiply the integral by -1 and nullify the -1 by multiplying negative in front. Then I can do a u sub. I can let u to be equal to cosine of x. So I have du to be equal to negative sine of x dx. And in place of negative sine x dx, I'm going to replace that with du. So the integral is now negative. The integral of du all over 1 plus u is cosine of x. So there are two of them. So this one is just a negative tan inverse of u. But what is u? U is cosine of x. So if we integrate this one, we are going to get this, right? So I'll just write that there. So integrating this one is going to give you negative tan inverse of the cosine of x, like this. And differentiating x is just 1. So this is how we can integrate that. Now, when we want to solve our integral, we just have to multiply the diagonal terms. We don't need to take the integral. But when we multiply terms horizontally, we have to take the integral, right? So now we can solve our integral. Our integral I now is going to be multiplying terms diagonally. That is going to be x, that is negative x, tan inverse of cosine of x. This one, like this. Sorry about that. So we take the limits of integration from 0 to pi. Minus multiplying terms horizontally. So this negative and this negative, when we multiply, that will become positive. So plus the integral from 0 to pi of the tan inverse of the cosine of x dx. So this is what our integral has been reduced to. So let's find the limits here. So if you plug in pi, that's going to be negative pi tan inverse of the cosine of pi, right? Minus, when you plug in 0, everything is going to be 0. Cosine of 0 is 1. Tan inverse of 1 is pi over 4, but 0 here is going to make everything 0. So the lower limit is actually 0, and that evaluates to just cosine of pi is -1, and tan inverse of -1 is going to be negative pi over 4. So that is going to be negative pi times negative pi over 4. And that simplifies to positive pi squared over 4. Then plus the integral. This is the integral from 0 to pi of the tan inverse of the cosine of x dx. So that is I. So I now is just this one, pi squared over 4 plus the integral from 0 to pi of the tan inverse of cosine of x dx. So the task now is to find what this integral is. How do you find the value of this integral? So let's do that. So this one, I can use the King's property here to find the value of this integral, right? The King's property states that the integral from a to b of f of x dx is going to be the integral from a to b of f of a plus b minus x dx. This is the King's property for definite integrals. So I'm going to use that here to find our integral. So I'm going to call this our integral I sub 1, which is equal to the integral from 0 to pi of the tan inverse of the cosine of x dx. And the integral that I'm going to transform using the King's property is going to be the integral from 0 to pi of the tan inverse of a plus b minus x. Here a is 0 and b is pi minus x. So that is going to be pi minus x, right? So we just plug in cosine of pi minus x. This is the integral by the King's property. And cosine of pi minus x, and that is cosine of pi minus x, is the same as cosine of pi, cosine of x plus sine of pi and sine of x. And this one is 0 because sine pi is 0. Cosine of pi is -1, so that is going to give you negative cosine of x. So this is the same as cosine of pi minus x. So the I sub 1 transformed by the King's property is going to be the tan inverse of cosine of pi minus x is negative cosine of x dx. Okay, so tan inverse of a negative angle is going to be negative of the tan inverse of the angle, right? So it's going to be like this. The integral from 0 to pi of negative tan inverse of cosine of x dx, and that is equal to negative in front, the integral from 0 to pi of tan inverse of cosine of x dx, like this. So this is the integral transformed by the King's property. So we can now add that to the original integral, which is this integral. When we do I plus I, that is I plus I, that is going to be the integral from 0 to pi of the tan inverse of cosine of x dx. That is this integral plus the one transformed, the I1, I'm sorry, plus the one transformed by the King's property, which is this one, negative integral from 0 to pi of the tan inverse of cosine of x dx, like this. So this and this are the same, so they will just cancel out. So 2 I sub 1 is going to be, this is 0, and then I sub 1 is going to be equal to 0. So that implies that this our integral, which is I sub 1, is equal to 0. So that leaves our integral I to be equal to pi squared over 4 plus 0, and that gives you pi squared over 4. So our integral I is going to be pi squared over 4 plus the integral I sub 1, and that is equal to pi squared over 4 plus 0. That is equal to pi squared over 4. Therefore, our integral, which is the integral from 0 to pi of 2x sine of x all over 3 plus cosine of 2x dx. This one evaluates nicely to pi squared over 4, like this. So that is how to solve this beautiful Stanford Math Tournament problem. So if you really find this helpful, make sure to smash the subscribe button for more engaging content from Calculus Diaries. I thank you so much for watching this video, and I'll see you in the next one. Bye bye.